Hey guys, this is Yusan, and in this video we're going to talk about 3.36 from the homework of Digital Signal Process 1. From this question, we know that this system is linear and time invariant, and we know the input and output. So in order to find Hz, we have to use this equation, which means we have to find the Yz and the Xz first. Let's start from Xc. We know that Xn equal to Un. So we could easily find that X equal to this one by using this Z transform pair with the region of Z bigger than 1. And look at output Yn. So what I do is just put out 1 over 2 time minus 2. So for this part, we could use Z transform pairs like this. So we could easily get this one. This is a constant from this one with the region of Z bigger than 1 over 2. So after that, we could easily use this equation to find Hz. And combine those two regions, we get the region of Z is bigger than 1 over 2. So let's plot the diagram of Hz. This is the unit circle. We are required to find the pole and the zeros. We know the pole is the point that make Hz equal to infinity. So if Z equal to 1 over 2, we could find that this part comes close to 0, which makes Hz come close to infinity. And if Z equal to 0, this part equal to 0. And if Z equal to 1, this part equal to 0. All of this make Hz equal to 0, so the zeros points are 0 and 1. The question A done. So let's move to question B. Find the impulse response Hn. We already know Hz from the above question, which is this one. I'm sorry. I try to use partial fraction method to get the inverse Z transform. So I rewrite this one into two combinations of this one. So if we get this one, we could easily use this Z transform pairs to get Hn, which is this one. So we get Hn. And the question C, we're going to find out whether the system is stable. To solve this question, we have to use this diagram again. We could find out that the RC curve of Hz includes the unit circle Z equal to 1. So the system, which means the system have the roots inside or on the unit circle. So the system is stable. And question C done. Let's look at the question D, whether the system is causal. So we know that the definition of causal system is that the output of a causal system depends on the past and the present inputs only, but not on the future inputs. But Hn, we know that Hn is equal to this one. It starts from n equal to minus 1. But when n equal to minus 1, we have to, in order to know the Hn, we have to know delta minus 1 plus 1, which means we have to know delta 0. And delta 0 is a future input, which means the system also depends on the future inputs. Thus, the system is not causal.